Hello everyone. Let's start solving today's LeetCode daily challenge questions. So question is Stone Game 5. So in yesterday's video we have solved the Stone Game 9, and before that also we have solved the 6th problem. And today the 5th one we are solving. So let's understand the question first. So there are several stones arranged in a row. Each stone has associated value, which is an integer given in an array stone value. So we are given an array, each has a stone value. Now in each round of a game, Alice divides the row into two non-empty arrays. So we have a row, Alice can divide into two non-empty arrays. The left row and the right row. That's okay. Then Bob calculates the value of each row, which is the sum of values of all the stones in that row. So first we have an array. Alice will divide that array into two parts. What we have? We have an sorry. We have an array which is stones array. Okay, stones. And then Alice, what Alice can do, Alice can divide this into two parts. This is the left and this is the right. Now what Bob will do is Bob will find the sum of what elements in the left, elements in the left, and this is the sum 1, sum 2, which is element in the right. Okay, now let's go next. What is given? Bob throws away the row which has maximum value, and Alice's score increases by the value of remaining row. If the value of two rows are equal, Bob lets Alice decide which row will be thrown away. The next round starts with the remaining row, and the game ends where there is only one stone remaining. Alice's score is initially 0, and we have to find the maximum score that Alice can obtain. So we have two, now we have two sums, one is left and one is right. So Bob, what it will do, let's say if I have sum 1 which is greater than sum 2, it will remove this, and now we have only this part. Let's say sum was someone was of left and sum 2 was the sum of right. Then if it is greater, we will discard, Bob will discard this part, and now our question is into this question, I mean in the game. Now this is our array. It will again Alice has to divide it into two if it is greater. But the remaining, this sum will be added to the score. Okay. This sum will be added to the score of Alice. And we have to maximize this score. Okay. So basically we have to divide this into two. Again we have to divide the same thing. Okay. So we have to again continue. Here if you see, it is given Bob throws away the row which has maximum value, and it will increase the value remaining. If the value of two rows are equal, okay, if two rows are equal, Alice will decide. The game ends when there is only one stone remaining. Okay, that means if now I have this part, now again for that part we have to divide it into left right, do the same thing. Bob will discard the maximum sum, and we have to, Alice has to use this sum too. Okay, this is the question. We understood the question. Now how we are going to solve this? Okay, so if you have seen, we want to find the sum first. Sum sum every time I have to find, I have this left half right half, I will find the sum. Let's say left we will discard right, again in left and right I will find the left sum right sum, again something will get discarded, again something. So what repetitive work we are doing, what repetitive work we are doing is finding the sum. So what we can do, so if you know about the prefix sum concept, then we can make use of that concept here. Prefix sum, first thought should be this, we will break down it little. Okay, now to solve the sum problem we have the prefix sum. Now if I have the prefix sum, every time I don't have to traverse and find the sum. Okay, so I have this so array, and if I make a cut here, if I have the prefix array here, prefix sum array, then easily I'll be able to find using the first index. If I have I and j, from I to j, I can find the prefix sum between I and j using the prefix sum array, right? That will be what, prefix of j minus prefix of I minus 1. If it is not, if it is 0, then it will be 0. Okay, minus 0. Now we understood why we are going to use prefix sum. Now first issue resolved that. Okay, now here if you see, every time how I will know that from left and right I want to maximize the Alice score, right? To maximize the Alice score, what we want the sum of left and right such that right is just greater than sum, but right is the greatest sum in that array. Okay, I mean, on the right side there will be multiple arrays. Sorry, sums. Let's say I have sum from here. This is the right. This whole thing is the right array. This whole thing is the right array. We want to make sure something is greater, but left should be just lesser than that, so that we get the maximum value. But we have to find again the all the sum and everything. Okay, so what we will do, we will go through first approach. In this video we are going to see the recursion approach and we will just optimize it. The solution will go to O of n cube for sure, but in this video we are going to see the recursion, and then memoization we will do. And if you comment on this video for the next optimal solution, I will also create the same video for that as well. Okay, but first understand this, we should go the step by step. Now if I have this array, okay, then if I have this A B C D E F G H, I am taking alphabets, it should be numbers. Now what are the possible way of cuts? This 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 okay, we have, if I have size n, I have n minus 1 possible way of cuts. Okay, now let's consider I made a cut somewhere here, and now we discarded this, we have to use only this. But here also I have to again make the cuts. But if you see, I have made a cut here, but that was a single choice. It's my choice that I'm making a cut here. It is Alice is doing it. I can make here or here or here or here. I don't know where to make, where I'll get the maximum value, right? So I have to go through each possible cases. So in such cases, what we can use? Okay, which algorithm or which technique we can use? We should use the recursion. Why recursion? If there are multiple choices, okay, choices, if we have the choices, if I can do cut here or here or here or here, definitely we can use the recursion there. Because there will be one case when I make the cut here, there will be another case where when I make the cut here, this will be my left, this here, this here. So we have to use the recursion. So we understood what we have to use now, recursion and prefix. What if for prefix sum is to find the sum, so that we can use the we can just find using two pointer, we can get the sum, we just don't have to calculate every time. Now to check the each possible case, we can use recursion. Now how we are going to use the recursion here is, we have how many cases is, see, we can get the sum. What will be my, let's say I have left sum and right sum. Okay, I have left sum, I have right sum. If it is less than, every time we are cutting, right? So anyway we will get the sum using the prefix. If my left sum is less than right sum will go. Okay, and only left sum. So what should I add? I should add score plus equal to my left sum plus, why recursion? Now if I have this I, let's say till k, and we have this k plus 1 to j. Okay, we made the cut here. Now my left sum, we are taking the left sum, that means we are discarding the right. So what will be my start and end here? I have I and k. Now my sub problem is I and k. So let's say if I am taking this as check or find, so what I have to do is check I comma k, if it was I comma j. Okay, if I have I and j, easily I can find the sum of what, left sum and right sum with k. Okay, now if else if my left sum is greater than right sum, so in that case we will discard the left one and then we will go with the right. So what we will do is score plus equal to, and we have to maximize, right? So this is just a score temporary variable, okay, don't consider it. Then write sum plus check of what, k plus 1 to j. Okay, and if they both are same, if my L sum is equal to R sum, then what will be my score? It is not, sorry, it is not plus, it is just equal to, or instead we will take the current sum instead, current score. Okay, let's not get confused. Let's take current and current. Then we have to maximize it, right? So my current will be what? My dot max of this both the cases, because it is Alice choice now, right? I can Alice can just discard the left or the right. So what we will do to maximize our value, we will take the maximum of that, what, check I comma k, or check k plus 1 comma j. Okay, now it should be L sum plus and R sum plus. Okay, now it will find the both and we will take the maximum of this. Now this is what this will be, go for R, k is equal to 1, because there will be, there's many kids cuts, right? 2 instead of 1 I can say I to j. Okay, from I to j this will go. Now we get the current every time, and after this what we can do is score is equal to max of this current comma score. Okay, we can do this. So we understood this logic. What is check? Check is the same thing. We are going just up and down. And if my I is equal to j, what will be my answer? It will be 0. And also if my I is greater than j, in case, then because here we are passing k plus 1, if my k is j, suppose if my k is j, in that case k plus 1 will go out of this, right? So in that case, if I is greater than 0, same return 0. That's it. We have to first find the prefix sum also. If you want the prefix sum video, let me know in the comment section. I'll definitely create one. Now let's start coding. First we are going to use the recursion, and I will tell you we will get the TLE after recursion. We will optimize it. Okay, now first find the prefix. So we want to use it in method also, so I will declare here prefix. Next I want the score. We can use it, or let's leave it there itself. What we can do is prefix is equal to new int. Let's take an n variable dot length, and the size will be n. Let's find the prefix. So what will be the prefix of 0? It will be stone value of 0. Now let's find the sum from int I is equal to 1, because 0 is already done, less than n I plus plus, and my prefix of I, what it will be, prefix of I minus 1 plus stone value of I. Just that's it, we got the prefix array. Now let's write one method. It will return the int. Instead of check we will use the sol, and we need a int I comma, or we will use instead int start comma int end. We just need two pointer. What I said, if my start is greater than or equal to end, then we will just return the 0. This will be my best condition is where start is equal to end, only one element is remaining. In the question also it is given, if you see one stone is remaining. Okay, there the game ends. Now int score is equal to 0. Okay, we have to maximize this. What we will do, for int I is equal to start, I less than or equal to end, I plus plus, I start to end. Now my each I is what? It is a cut. Okay, so what we will do is you it should be start plus 1, or we can take a start. It will just remove the e. Int left is equal to, what was our left sum. Left sum will be prefix of I plus 1 minus, if I'm correct, my start is end is, if my I am on the I, so if I'm going uh, prefix of I plus 1 minus, wait, I'm doing something wrong. So we should start from start play. If I my pointer is this, the next cut should be here, so add this. Okay, in that case, if my prefix of I, my left should be prefix of I minus. Now here the condition comes, if my start plus 1 is less than 0, okay, less than or equal to 0, then we will take prefix of start minus 1, else we will take the 0. Okay, now int right is equal to prefix of end minus, prefix of end minus, what will take for the right, prefix of I minus 1. Okay, this is correct. We got the left and right. Now what is our this, we will check. If my left is less than right, then there will be one condition. Else, if my left is greater than right, or else if both are same, it will come here. Okay, if it is less than right, then what we will do is current, we'll take the int current is equal to 0. My current will be left sum plus same solve with what we will pass is I and j. I will be start, and what will be my j, I mean what will be my end will be my I. Now here my current will be right plus solve, it will be I plus 1 comma int, correct. Now here current is equal to mat dot max of this comma this. That's it. Now we get the current, and what we have to do, we have to score plus equal to that current, we have to add that, right? And then at the end we have to return that score. Every time we'll get the score here, and then yes, and we will do same here, return sol 0 comma n minus 1. Yes, let's run this. Okay, we are getting some issues. Let's see one by one. We are here, we are starting from the start plus 1. Let's debug it. Okay, and we have left, and left for we have to find this. So yes, we did one mistake here. It should be I minus 1, because the last element for the first group should be I minus 1. Now if my start of, okay, I did again mistake, start minus 1 should be greater than, not less than, should be greater than or equal to 0, then only I can use that prefix start minus 1, otherwise I'll get the array out of bound index, right? This is correct. Now same thing, if you are doing, if my last element is I minus 1, here it should be just I, and same thing here, because we are using just the I issues, but the concept should be clear. And also see, while explaining, I explained with the max, and but I did the uh, addition, mat dot max score comma current, and Yes, I think that's it. Let's run this. I hope it will work this time. Yes, it worked. Now let's submit. We'll get the TLE. I'm telling you, because this is just a recursion and we are going to optimize it. But let's wait. Yeah, we are going to get the TLE. We got the TLE. Now how we'll optimize? See, what we are storing, not storing, but what we are doing, I to j we are finding. But here for this I to j range, again we will do the cut, but again I have the same thing, right? I to j. So what we can do is we can memoize it, like we can store it from that I to end. If start and end are same, why we need to calculate again? So let's do it in dp. Okay. Now what we'll do, dp is equal to new int. The size will be n and n. We will initialize it. Okay, for int, let's say ar of dp arrays dot fill this ar comma minus 1 will fill the minus 1. Okay, and we are going to use here dp. So what we'll do, if my dp of this start and end, if it is not equal to 1 minus 1, that means something it is there, we have already stored. So we will return dp of start and end. Okay, how? But we have to store calculate also, right? So dp of we already calculated once, then end is equal to, we will use the score. Okay, that's it. Let's run. Now let's submit this. Now this will get accepted. Yeah, you can see it is accepted. So this is recursion plus memoization. So this is one of the solution for this question. We have one more. We can further optimize it, but this video will get long. If you want to know that solution, or if you want me to explain that in a proper way, in a simple way like this, let me know in the comment section. I will definitely create a video. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.